It's slightly different than the book's answer, so don't expect it to match what the book has. I changed it slightly. So just do that. Um, have your eyes wide open as you go, okay? You'll understand in a second what I'm saying. Whoa. Unless your eyes are closed, in which case you won't. What? What? Yeah, that's allowing you are not seeing children.
Oh, cool.
You're doing it right, but you're doing it wrong. No, it's not ahead. Better the long way and get there than just stay in place and get there.
Well, you're gonna get to eventually teach to it.
After I carry you there, that's. Until we get there and
Well, exponential, but oh, there you go. It's just a little bit.
make sure you don't go that way.
Oh, well, that's just write that down. I'm glad. Show us.
Okay. What's wrong with that?
It's ugly.
It's not right.
It says no.
The function is a function of x, but over here you see, that doesn't seem quite right. Okay, that's a no-no. If when you go to use notation and you're not darn sure it's f of x, then it's much safer to use Leibniz notation dy dx. Because then it doesn't need to be a function of x or y. It can be whatever it wants, a relation between x and y. Okay? Now, the next then would be to maybe separate the variables, yes? Okay? And to me, that also would be a... Now that is true, and you're going to get there, but you're not seeing it all. You're not seeing it all. This is a famous differential equation. It is the equation, the amount changes, or the amount of the dependent variable changes at a rate proportional to the dependent variable, or how much dependent variable you have. That is the most famous differential equation. So my hope was that you would see this and say, oh, that's exponential growth. Instead of A is the initial amount times the growth factor. In this case, it's more like y equals initial y e to the, there's k right there, that's k, 2 t. Now that's not quite complete. What now do I do? There's no c, although if we integrated it would have had a c, that's true. That c would have actually, I know it doesn't look like a c, but that c actually would have been rolled in here. That's kind of the c, sort of. So how do you find that? Yeah, you need to plug in y initial, plug in the point to find y initial. If I use 1, 1, then I get 1 equals y initial e to the 2. So y initial is 1 over e squared. And so my equation is y equals e to the 2t over e squared. What other form might you see in a multiple choice if they clean that up algebraically? E to the 2t minus 2 also would be possible. Now that is absolutely where you would get if you continued on this way too much worky kind of path. You'd get there. Log of 1 equals 2 plus c. C is negative 2. Log of y equals 2x minus 2. Y equals e to the 2x minus 2. Y equals plus or minus e to the 2x minus 2, choose plus. You get there, but it's way too much fun. Okay? Are you with me? Okay. You get there, like I said, you just get there as long as I don't have to carry you there, I'm happy. Okay? Okay. This is a rather, hang on, sorry, let me put the slides. Actually, let me rearrange the slides. Boom, 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 boom,
It wasn't just very
boom, boom. Sorry. Okay, I apologize. Here we go. If I asked you, hey, could you average 5 numbers? Could you? Darn right, you could. Could you average 10 numbers? Darn right, you could. Could you average infinitely many numbers?
Heck yeah.
Darn right, you could. With calculus, you can average infinitely many numbers. Infinitely many numbers. This blows your mind. Are you ready to have your mind blown? Boom. Here we go. The answer to that's always yes. Here we go. Just curious. Could you look at those 5 numbers and tell me what the average is with no calculator in 10 seconds, 5 seconds?
That's 98. Wait.
Good guess. It's wrong, but try again. 90. Okay. Now, I assume you did not just add all those numbers and divide by 5. How'd you come up with 90?
Looks like it would be 90.
Okay. Justify why you can show it really is 90. It is 90. You can start by eyeballing it and say, yeah, it looks like it's in between. What do you know about 88 in relation to 90? It's 2 below. What do you know about 92 in relation to 90? It's 2 above. What do you know about 84 in relation to 90? 6 below, and 96 is 6 above, and 90 is right at 90. And so because it's perfectly in between all the up and down differences, it is exactly the average. The net above and below should be 0. That's what makes it perfectly in the middle. You with me? Now, if you were to graph this, and I said, let's look at 90 and then 88. Shoot, I didn't make this big enough. 90, 88, 86, 84 on the bottom end, and 92, 94, 96 on the top end. My theory is that 90 is the average. I know that 88 is here, and 92 is a little above, and 84 is quite a bit below, but 96 is quite a bit above, and 90 is there. Now, if you look visually about the difference, the area of that red bar would be exactly the same as the area of that red bar, except one would be positive, one would be negative. Yeah? So they would cancel each other out. And then this red bar below and this red bar above, again, would cancel each other out. And then this, so the net result is the above and below areas of the red would cancel each other out. Do you think? And you might think, that's a big deal, so what? Well, that's the idea behind the calculus of what we're talking above and below the average value is the key to finding the average value of a function. This, to me, is cool. Imagine if I charted your velocity on the way to school, and you're probably something like way up here, and maybe you had to come to a stop, and then maybe you didn't go back in time, never mind on that, but you, like that, yeah? Your velocity would vary completely over the whole trip, yeah? And yet, I could find an average velocity on the whole trip with calculus. The idea goes like this. So imagine you had a curve that looked like this, and the goal, this is f of x, the goal is to find what's the average y value over the whole interval. I think you'll agree that the average y value would have to be somewhere in between the top and the bottom, so maybe somewhere in there, except it would be straight, yeah? Let's try that again. Now, that's an average y or function value, so I'm going to call that f at c. It's not f at a, and it's not f at b. It's probably f at some other value, c, I don't know. It's got to have some average value in there. How do we go about finding it? Well, consider two areas. If that's truly the true area, if I chop this region, if I chop this region, and and use it to fill that, then wouldn't I be completely flat? The above and below would be goners, and it would just be a flat top, right? Okay, now that area then would look something like if I took that flat top, then this piece would be filled, so it would look like a rectangle, right? Rectangle. Chop above, fill below. Okay? Now that rectangle, what's the base of that rectangle? That gap b minus a, right? Do you agree? Okay. What's the height? F at c. It's that average value you're looking for. Now, all that's great, but I don't know. That really gives two unknowns. I know the base. I probably know the region. But I don't know the area, and I don't know f at c. So that's two unknowns. No starter. We need something more. What else do you know about the area? What do you know about the area of that rectangle? And how does it jive with the original problem? The area of that rectangle is the same as the area under the curve. I mean, if I didn't just chop that area, wouldn't this area here under the blue be exactly the same as that green? Do you see what I'm saying? If I just left it alone and found area under the curve, it would have been exactly the same area. So this equals the area under the curve. Had I not, oops, that's not very good. Had I not chopped and filled, you get the idea. Well, how would you find that area? An integral from A to B of the curve, right? Now, putting those two ideas together is what's going to allow you to find that average value. If area 1 equals area 2, then the area 1 is the area of a rectangle. It's the base, b minus a, times the height, f at c, the average value we want. That equals the area under the curve by calculus, the integral from area a to b f of x dx. With that then, the average value of f, which is f at c, could be found by what? Self-referencing. Divide. Now you could put it under the root, or under the integral, but it's usually put out front. 1 over b minus a times the integral from a to b. It's not wrong to put it under the integral, but it's just typically written up. That's how you find the average value of a function. Now it feels like, again, if I just put this up there, it feels like, all right, whatever, it's an integral with something divided out, y. The y, I want you to understand, it really comes to filling the hole and equating the two areas, rectangle versus area under the curve, all right, and then solving for that average value. Now this leads to actually several different types of problems and a little bit of confusion in terms of verbiage and the wording you're going to see. I'll get to that in a second, but let's start off with a pretty straightforward. If the question says, find the average value of that function on an interval, then you're just trying to find what's the y value on average of this. I know that 3x plus sine of x probably looks linear, but with some waviness going on because of the sinusoid. The combination function would look something like that. Not that you need the picture. On 0 to pi over 2, it would be, the average value would be maybe in here. If I were to visually try to find the average value, I would try and graph it in such a place where the area above and the area below would negate each other, so I maybe placed it wrong. That's it. You with me? You're just going to find, this is the goal. What is that average y value, average function value? It's the integral, 1 over pi minus 2 minus 0 from 0 to pi over 2 of 3x plus sine of x. And we do a little calculating. What's the cleaned up version of 1 over pi over 2 minus 0? 2 over pi. Okay? What's the antiderivative of 3x, Mr. Flannery? 3 halves x squared. What is the antiderivative of sine of x, Tanner? Negative cosine of x in truth. 0 pi over 2. This will get ugly, and that's fine, I'll just leave it ugly, but maybe something like 3 pi squared over 8 minus, what's cosine of pi over 2, right? Cosine of pi over 2, 0, okay? And then 0 minus, what's cosine of 0, Mitch? 1. So maybe something like 2 over pi, 3 pi squared over 8. I think you'd end up as a positive one then. At that point, it's fine. But that's the average y value of all the, there are infinitely many y values on the interval, and you found the perfect halfway point. You with me? Okay. Now then, here's where the words start to get a little complicated. This is unfortunate. If I could go back and slap the mathematician that decided to word it this way, I would. But it goes like this. Sometimes you don't want the average value. You want, where is that average value made? What point on the curve does that occur at? In that case, then, instead of just finding the average value, you're actually finding the x where the average value is made. Think of it like this. If you had a curve here, the average value would be in here somewhere, f at c, but the question might not be what is that y, but rather what is this x, where that's made. Especially for physics purposes, it's sometimes important, you'll see. So the mean value theorem for integrals, which right away will get confused with the mean value theorem, period. If they say mean value theorem, stop. That's the old mean value theorem. The average rate of change equals instantaneous rate of change, the old one we've been doing, right? If they continue on and say for integrals, then they're talking something totally different, and you need to understand there's a huge difference. In plain old English, all this stuff says that if f is continuous on the interval, there must be an x that makes the average value. That's what it is in plain old English. If f is continuous, there must be an x equals c that makes the average value. I should have put this in my notes, but just go off to the side. Top y continuity. Would you graph for me a step function, something like a bar from 0 to 1 at 1, and then another bar from 1 to 2 at a y of 2? And the endpoints don't really matter. Okay. What's the average value of the function on the interval? 1.5, right? Is there a place on the curve where that 1.5 is made? There is. Okay, that's the idea of, is there a place that makes the average value or not? Well, continuity is required. It's got to go smoothly from one to the other to make sure it passes through that average value. Without that, you can't really be sure that there is such a place where the average value occurs. It has an average value, but it's not really a place on the curve itself. This is what a problem will look like. Again, you're going to have maybe 2 or 3 different problems, and you're going to have to decide with practice, is this where I find the C, or is this I just find the average value? With practice, and use your notes. But if it says find the C, then you're going to work both sides of the average value, and your answer should be C equals this. Okay. Now, first of all, this is continuous, so there can be such a C. There must be such a C that makes the average value. I know that 2 plus x cubed would pass through a y-intercept of 2 and go like that. And at 1, what's the value? What's the function at 1? 3. And what's the function value at 2? 10. Okay. So I know that the average value on that interval was probably somewhere between 3 and 10, maybe in here somewhere. I don't know. So I'm thinking maybe, I don't know. I think it's a little less than halfway, maybe 5 or 6. That is my ballpark guess. But the question isn't this, what's the average value, but this. What x on the curve makes that average value? Do you understand what we're looking for? Okay. So f at c then, if I work both sides, then f at c would be 2 plus c cubed. That's what the equation equals at any point. And the right side then calculates the average value. So I'm going to say 2 plus c cubed needs to equal, or at what c does 2 plus c cubed equal 1 over 2 minus 1 times the integral from 1 to 2 of 2 plus x cubed dx. You follow? Are you with me? Sure. Okay, cool. Thank you. 2 plus c cubed equals 2x plus 1/4 x to the 4th from 1 to 2, unless I made a mistake on my antiderivative. 2 plus c cubed equals, what? 4 plus, what's 1/4 of 2 to the 4th? 4 minus 2 plus a 4. So I'm looking at something like 8 minus 2, or 6 minus a 4th. So 2 plus c cubed equals 6 minus a 4th, or 5 3/4. What's special about 5 3/4 for this problem? What is it? What did I just find at that side? That's what? Yeah, that's f and c. That's the average value on the function. We know it was between 3 and 10. The average value is actually 5 3/4 over here. Now the question though is, all right, now find the x where that happens. So if we now continue on, c cubed would be 23/4 minus 2. What's 23/4 minus 2? 15/4. So c is the cube root of 15/4, or I guess the cube root of 3 3/4. Cube root of 1 is 1. Cube root of 8 is 2. So is our answer between 1 and 2? Yeah, it's in there. It's where it should be. Okay. All right. Are you tracking? It's important that you understand what's going on each side, because the great gotchas on multiple choice problems are intermediate answers, and I'll explain in a minute. Would you get out your calculator, please? So you're given this function, 7 plus sine of 2x. Find the c guaranteed by the mean value theorem for integrals on 7 to 8. I would start by saying, all right, I need to find c in this idea. And because I'm finding c, I'm not just working the right, finding the average value, but I'm also working the left and going to solve that for c once I'm done. So, great. What do? Get me started. Say again? Yeah, 1 over 8 minus 7. The right side is 1 over 8 minus 7 from 7 to 8 of 7 plus sine 2x. Okay? With calculator, that's pretty easy. Evaluate that, please. And would you throw 3 decimals at me, please? I'm thinking this. You have something like that? Okay. Here's one of the great gotchas of the AP test. Don't let them get you. They will often, I'm talking often, throw as multiple choice answers a number that comes up in the course of the problem. And they'll get you to buy, oh, there, oh, that's there, I'm done. Yay, I don't have to do anything more. And in fact, you're actually ignoring the fact that you didn't find what you were supposed to find. You're just so happy to see something that looks familiar. Woo, circle. Okay? Don't let them bait you. Remember to answer the question. You haven't answered the question yet. The left side is what I need to now work. This is 7 plus sine of 2c. So now I need to answer that question. How do I proceed from there? Subtract. Sine of 2c is 0.5472. And then what?
Use inverse sine.
Use inverse sine and divide by 2. And what do you get there? Second, 0.289-ish? Yes?
Yes.
Okay, so there's my answer, right? Wrong. 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 Where should C be?
Oh no.
C better be between 7 and 8. Okay? So you're asking, you've got this sinusoid, and they're asking in 7 to 8, not somewhere else on the curve, in 7 to 8, where is the average value made? Now, because you used arcsine, it looked for the closest possible answer, closest to the origin kind of possible answer, because that's what arcsine is programmed to do. Negative pi over 2 to pi over 2. It doesn't know you want 7 to 8. You need to then work that issue out. So this is not good. And I got to tell you, I would have actually started the problem by saying, all right, got to find a C in 7 to 8. Boom, that's already done. You're not going to get me with that one. That's gone. I don't even go there. Scratch it before you even start the problem. Not possible. Not possible. Okay? So that you don't make that mistake later. So there's a couple ways to do it. You could consider what's the period of the sinusoid and say, all right, a couple periods later, what's that? That's going to lead to mistakes. Go back to here. Given that you have a calculator, what's another way to solve that equation? Graphing. Yeah, it's better if you're looking for cases that are not in the normal arcsine kind of region to graph. If you graph y1 equals sine of 2c and y2 equals 0.5472. Then you can set your window to 7 to 8 and be sure that you're looking in the right place. If you did that, just for the sake of time, it might look something like this. I don't know if you can tell, but my window is set from 7 to 8. I'm looking in the window I'm supposed to look. In the place where those are matched is at 7.564. And so my answer, use graphing tab, use graph, is, okay? Questions so far? All right. So this is the last thing. I don't know if you remember last Friday, those of you who were here, you did that AP practice, 10 multiple choices and free response, remember? There was a question on there that was average value, it said, I can't remember how it was worded, but it's, oh, there it is. Hang on 1 minute. Okay. It was this question here. It said, what's the average rate of change on the interval? Okay. Now, I think your class hit this at maybe 90% success, maybe 95. I did the same thing to BC, and their success rate on that was more like 60%. Yeah, it's the only time that's ever happened like that. But the problem with that is the why of it. There's really only one thing that goes through your mind when you see average rate of change. You do secant kind of slope, right? There's average rate of change, right? Like you've been doing forever. The problem is that they also have in their mind, well, there's average rate of change and there's average value. And which one should I do? And they got confused, and many of them chose wrongly. That's now, because you have two average ideas, two mean value theorem ideas, you're going to get confused, and you need to read very carefully. So as a way of compare and contrast, so that you don't make that mistake. I saw that so much that I add this onto my BC notes, and hopefully this will help well. Excuse me. Say you had the average, or the velocity equation on 0 to 10. These are all different questions that could be asked on that same given. Find the average velocity on the interval. Average velocity on the interval. How would you do that? If I gave you position, how would you find average velocity on the interval? What's velocity? Change in position over time. So if I gave you position, you would do this. Isn't that average change in position, which makes it average velocity, right? Okay. The unfortunate problem, though, is you don't have position, you have velocity. So it says average velocity. It's really like saying, I know that the velocity is constantly changing here. I want the average of all those. So what do? You do this thing we did today. If you're given the average velocity, it's like being asked for the average value of what you're given. So it's an average value problem. And you set it up something like this. Some books will call this V bar for average. That's pretty common in math notation. 1 over 10 minus 0 from 0 to 10 of 3 plus t squared. And you go about your way. I don't want to confuse you, but I also want to feed those of you who are so brilliant, okay? Side note, this is velocity, right? What's the antiderivative of velocity? Position. So if you anti-differentiated this, wouldn't this be position at 10 minus position at 0? Isn't that average velocity? Yeah. So that's actually another way it's developed, by the way. Backwards kind of way. What if they asked for not average velocity, but average change in velocity? Then what do you do? Change means you're looking at the differences. Velocity at 10 minus velocity at 0 over 10 minus 0. What does this mean? What is this average velocity thing we're calculating? Change in velocity is Acceleration. I'm really finding the average acceleration on here. Okay. Other kind of variations. Find the C guaranteed by the mean value theorem. Period. Mean value theorem. Period. Not mean value theorem for integrals, mean value theorem. Is that the original mean value theorem or this new integral kind of mean value theorem? It's the original. So you're looking for where more like the average rate of change equals the instantaneous rate of change. So you say V is continuous and differentiable. And you'd say something like V, the instantaneous change in velocity, must equal the average change in velocity over the interval. It's more like the old one, mean value theorem, period. But if they said, find the C guaranteed by the mean value theorem for integrals, read carefully, please. You're going to go the wrong way if you don't read super carefully. Mean value theorem for integrals, then it's more of this idea, not F so much, but V at C equals 1 over B minus, or 1 over 10 minus 0 rather, for this problem. And when you solve this, are you looking for a V or a C? And C, what is it in terms of this problem? It is is that a time or a velocity? Time. It's the time when the car is going its average velocity. It's the instant when it's hitting that average velocity, right? I think that's what I wanted to get across. Are you down? Okay. All right. Yesterday's homework. Let's go over that if we have time. We'll go through as much as we can, and whatever we don't get to, questions, I'll grade you for giving it a shot, not getting it perfect. I just want you to try. And I do want you to try as much as you can on your own steam. I understand you can pair up with somebody. Yes? Sure. I understand you can sit next to some brilliant student and just say, and write down what they tell you to write down. But you're not going to be able to do it on your own. So I'm really talking to like 1 or 2 people there, maybe 2 relying on other people. I know it's tempting to do that, but fight that till first. So number 1, I have maybe y equals negative 2e to the 1/3 x cubed. Bless you. I'll give you answers, and then I'll be happy to go back over questions if you have. Number 2, y equals 1 plus the square root of 7 minus 6x. Am I right? Or f of x if you like. Okay. Number 3, I have slightly less confidence in my answer because it's so stinking ugly, but this is my answer. Negative natural log of negative 1/2 e to the 2x plus e to the negative 7 plus 1/2 e to the negative 12. I don't hear a lot of on that. I didn't see any mistake in my work. Is that what you got? Excellent. Okay. So it just is that here. All right. This I think. Oh no, this is right. The words, the verbal description of exponential growth, and I'm really talking about the exponential growth differential equation, is the amount grows proportional at a rate proportional or just proportional at a rate proportional to the amount. Now, if you were to decode that from words into calculus, the differential equation is the amount grows at a rate implies dA dt. The rate of growth, the rate of change in the amount, is proportional to twice as much, 3 times as much, 4 times as much, some number of times as much as the amount. Proportional means there's a scale factor. Okay? And that factor is k. Equation for exponential growth or decay. If you integrate and do a little bit of absolute value work and finding the key C and then rolling the C into A initial, that's where exponential growth or decay equation comes from. Okay? So, getting into a specific case. The amount doubles every 4 years. if I asked you for an equation for the amount as a function of time, then am I looking at differential equation or amount equation? First one or the second one? Second one, the equation for the amount, not the differential equation that's fuzzy. So I'm going this way. Do I know the initial amount in here? Not really. Can I extrapolate from what they give me to the k? What's the k? If the amount doubles every 3 years, then it's a 1 to 2 proportion, so k is natural log of 2 over 3. Okay? Pause for a second, again, just to see something cool. This, wouldn't you agree that this is equivalent mathematically to this? I could split the natural log of 2 into 1/3. Cool. Wouldn't you also agree that that's the same as take the natural log, then the third? And what is e to the natural log of 2? 2. So it's this amount equation is really the initial amount times a factor of 2 for doubling every 3 years. If 3 years passes, you'll double once. If 6 years pass, you'll double twice. So every time you see this E equation, which I know looks hairy, remember it all goes back to it's growing by a factor of something. In this case, it's a factor. It can be cleaned up. It's just that E is so nice for calculus. We like to keep that E in there rather than take derivatives on that, which is nice. Okay? The differential equation for this problem. What is it? Given that I at one time had K clearly identified. The ADT equals natural log of 2 over 3 is my K value for this problem. T or A? A, yeah. Okay. This is a bit of a gotcha question. I guarantee you, if I asked 10 people on the street this question, I guarantee 9 at least would say the wrong answer. House values in Denver increased 45% in 5 years. What's the growth rate per year? They're tempting to say 9%, right? But does it grow 9% of the same amount every time, or is it 9% of a new amount every time? In other words, is this exponential growth or linear growth? It's exponential growth, okay? We know that that's not quite the same. It's probably a little less than 9% to start with, and then a little more than 9% later. So there's a little more to it. And that's why this is cool, because it's like only a problem for smart people. So, differential equation, I wasn't quite sure. I want to get the differential equation, I would need K, right? Okay. So how do let me play around with the amount equation. Give me a case. I don't know A initial, so I can't put that in, but give me a case. What's an amount later in time? 1.45 or 1.45? 1.45. It's 100%, everything it was and 45% more. So a later case is 1.45 the initial amount after 5 years. Okay? So 1.45 equals e to the 5k. So natural log of 1.45 over 5 equals k. That allows me to solve the differential equation part of the question. dA dt is natural log of 1.45 over 5 times the amount. Cool? What about the other questions? A little harder. What percent did values increase by per year? What do I do? Say what? Give me something. Let's talk this equation. What could you tell me in that question? Do you know K? Do you know T? The question is per year, so how much time? 1 year, okay? So if I were to say how much happens in 1 year, then what is e to the k? Which actually I guess would be 1.45 to the 1/5 or something like that. What is it? E to the k, please. E to the log of 1.45 over 5. 1.077. Okay, right. Does that mean the growth per year is 107%? No. Every year it's growing by a factor of 1.07, so as far as percent growth, it's 7.7%. Now, because of the compounding, that's how it's getting up to 45% total. Okay. I might have had these in the wrong order. Is this the next problem? Or is this slide? This is right. Okay, I have B for this one and C. Okay. My K was natural log of 0.8 over 4. Okay. This one, I don't know if I formatted this correctly, so I hope you didn't start doing the problem until you got to A. There are two methods to this, and one's more by test strategy, and the other one's by math. I want you to compare and contrast. If they said slope of dy dx equals 3 or equals this, then I could use separation of variables and differential equation work and all that stuff, right? And that's a lot of work on a multiple choice problem. So my point here is that maybe we can get at this a different way, a little easier way. One is, if the curve has to pass through 1, 2, does that drop out any solutions? Do any of those not give you a y of 2 when x is 1? And I found that that dropped out actually. B and C both drop out for that. Those don't yield 1, 2. So they're out. When I put in an x of 1, I do not get a result of 2 for those. Furthermore, couldn't I know that the derivative at 1, 2 should be something like 3 plus 1 times 2, or 8. The derivative, or the slope, should be 8. Because this is calculator, I don't even have to do these derivatives by hand, although I could here. What's the derivative of this one? 2e to the 3x minus 3 times 3. If you do that at a 1, what do you get? 6. Can that be it? Derivative is wrong. So it's not D. The derivative is wrong. So it must be. Okay. Now, you could also do it the separation of variables you kind of way. And so that is the kind of the skill of the day, so I wanted you to get practice on that too, just to compare and contrast. But natural log of the absolute value of y equals 3x plus natural log of the absolute value of x plus a c. You could use 1, 2, and that also would get you that it must be. If you'd like to see that process, I can show you, but or you can just take a word for it. Number, oh, Doc, on it. This is the last part of the notes, wasn't it? I'll come back to it tomorrow. Dang it. Sorry, I got my slides out of order. For this one, I have the right. I have D here. Yeah. And B.
Good morning, Grandma Jack Black. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And now for today's episode of Hack My Life, featuring Chipotle, brought to you by the
C for 11.
You can double your rice and beans and add the veggies to any entree at no extra cost. Try this out when you come support the team at Chipotle in Omaha on February 27th, next Tuesday.
Boys volleyball team, if you need forms or to drop off forms, please see Miss B today.
Members of French Honor Society, there will be a meeting tomorrow during 7th hour in Mr. Soft's room.
Oh, I didn't.
Big Fish musical crew and orchestra, make sure you stop in the auditorium today right after school to collect an important note from Mr. and Mrs. Clover.
Colorado Christian University in Lakewood will be visiting prospective Dublin students on Thursday, February 22nd.
So
Check them out and see what
G is, if the derivative is negative, G is
Arapahoe Community College is
decreasing, right?
Open today on Friday, March 9th, from 9:30 to 1:30
Okay,
at the AAC.
this, we haven't done a lot. What's the derivative of that with respect to x? 1 plus 2 is y to the x.
Saturday, February 24th, from 10 to 2 p.m. at the Marriott Courtyard, Cherry Creek.
Okay, so the second derivative
Alumni, admissions counselors, and
at
more
0,
are
negative 1
at
is 1 plus 2 times
37th
0
hour
minus
today,
2.
Colorado State University, Fort Collins, home of the CSU.
Less than 0, so
All
concave
students are open to all students,
down,
so we'll see you
it
there.
The Dublin Spanish Honor Society wants you to come and check out the super sweet bracelets for sale during lunch this week. Only $5 will get you a full gift and support the sustainable program for Central American artisans.
Now is your chance to see Big Fish. Show your student ID at the door this Thursday, the 22nd, and Friday the 23rd only,
Sure.
and get into the show for $5. Shows begin at 7 p.m. Yes, only
So that's
$5.
tempting, but it's not the differential equation for exponential because it's divided by y. So I did separate the variables.
Thursday through Saturday. Come on out and support your double and drama program. Did we say only $5 with the student ID?
Senior high students, attention all high school students potentially interested in taking AP Physics, Chemistry, or Biology next year. There's an important informational meeting tomorrow during 7th hour about 42 to help you make an informed and appropriate AP choice for next year. Please sign up in your current science teacher's class for 7th hour Thursday to report directly to the auditorium. See you there.
Zach, all athletic forms and fees are due today. Please bring them to the attendance office.
NHS students, please remember to get your
You
dues
with me?
into Mrs. Stevenson by February 20th.
So, because it's got to be positive.
Thank you.
All juniors and supplementary
Because we're talking about it
and
again, so.
composition next year.
So finding the K,
Informational meeting and involved
equal
with during those hours today. Please sign up with your English teacher.
Junior high students, come join your friends at our big skate party at Skate City on Friday, March 9th at 3 p.m. There will be a Skate City fun bus for
Skate
anyone
City.
to ride the
Did
park.
I go?
Information will be handed out in the non-stop
It didn't come true.
Athletic the boys basketball team is advanced to the playoffs, and our first game is this Saturday at 7 p.m. in Dublin. Go Jack. Also, please wish Mr. McGuire a happy birthday today. He's just 29 and looking fine.
At least make it pretty.
That's all you
Ah,
have to say.
close. How about 40? That's my y equation. Now I can do y at 18. That's 144 plus 25. So that's where they can split it up. That makes sense. Anything else you'd like me to work out? Okay.